Today we're going to be looking at right triangle trigonometry. And we would need this if we don't have two sides of a right triangle to help us find the third side, or we don't have either acute angle in a right triangle. And so what you're going to see here at the top of the page is the acronym SO, CA, TOA. SO represents that sine is the opposite side over the hypotenuse. CA means we have for cosine adjacent over hypotenuse. And TOA is tangent is opposite over adjacent. Now, it is important to notice that if you look right here, I have my angle theta, and I typically use x or theta to represent my angles. From this perspective, if I was to draw a little person over here, and I was on this perspective for this angle, opposite would be over here, and the side I could touch would be right here. This would be adjacent. And of course, always across from my right angle is the hypotenuse. That'll never change. Now, let's say I draw in a blue person. From this person's perspective, this side would be opposite, and this side would represent adjacent, right? So it's important to note that the opposite and adjacent sides can switch depending on the perspective, but the hypotenuse is always going to be across from the right angle. All right, so let's try setting up some ratios. We're just going to set up the ratios. We're not going to do any calculations. It says use the given triangle to find the exact values of sine, cosine, and tangent functions. All right, so first of all, you'll notice that we only have two of the sides, but we're going to go with the Pythagorean theorem to find the third side. That's a little easier than using trig, so we're going to do that. So we're going to use a squared plus b squared equals c squared. Sides A and B will be the legs, and c squared is the hypotenuse. So we have 4 squared plus 3 squared equals c squared. To undo a square, we take the square root of both sides. And so we see that the value of the hypotenuse is 5. And I'm just going to write that in. So we're going to find the sine, which is the opposite over the hypotenuse. We're going to find the cosine, which is the adjacent over the hypotenuse. And we're going to find the tangent, which is the opposite over adjacent. So we have SO, CA, TOA. Now, we're going to come over here and we're just going to kind of like highlight or make it really clear. That's where our angle is. So the hypotenuse is always across from the right angle. So that's taken care of. And then opposite my angle is this side here on the opposite side, the opposite leg that I cannot touch. And the leg that I can touch is going to be adjacent. And all I have to do to find the ratios is I just have to fill in the numbers now. So my opposite side is 4. My hypotenuse is 5. For cosine, it's going to be adjacent over the hypotenuse. That's going to be 3 over 5. And the tangent is going to be the opposite over adjacent, TOA. And that's it. It's really that easy. Okay, so we're on page 2. This is example 2, and they give us our triangle. They tell us angle D is the right angle, and they tell me that the tangent of E is 3 over 4. So it's important to note right here that my angle of perspective is E. So I want to label my sides. Across from the right angle is going to be my hypotenuse. The leg opposite my angle is going to be this side right here. That's opposite. And the leg next to my angle is going to be right here. Now they tell me that the tangent of E is 3 over 4. I'm going to write my acronym at the top here. So, ka, toa. So I know that the tangent represents the opposite over the adjacent. So my opposite side from angle E is going to be 3. My adjacent side from angle E is going to be 4. And now I can use the Pythagorean theorem to find my hypotenuse. Again, the Pythagorean theorem is a squared plus b squared equals c squared. The hypotenuse is always on the side by itself. It's represented by the letter c. So we have 3 squared plus 4 squared equals c squared. Take the square root of both sides, and we find that the value of c is 5. So we're given the tangent of E. All we have to do now is find the sine of E and the cosine of E. We're just finding the ratios. We know that sine is so, it's O over H. We know that cosine is ca, it's A over H. And we're just going to go ahead and look at our diagram and fill those in. So the opposite side is 3 and the hypotenuse is 5. The adjacent side is 4 and the hypotenuse is 5. All right, and that takes care of example 2. So that's how we find the ratios. Now we're going to take it one step further. If you're given the measures of an acute angle and the side of a triangle, we can find the length of another side. We want to make sure we're in degree mode, so we're going to do that first. If you could please go to your calculator. We're going to press the mode button, and we're going to make sure degree is highlighted. If it's not, you would just use the arrows to go over to it and hit enter. Once you're sure you're in degree mode, you can quit. Now, some calculators will show the mode at the top, so you can always look there as well. So we have example 3, using a right triangle to find the length of a side. In a right triangle, the length of the opposite 5-degree angle is 3 feet. So let's make a note here. We have a right triangle. We've got a 5-degree angle. And the leg opposite the 5-degree angle. So if I travel and I look at the leg, not the hypotenuse, the leg is going to be 3 feet. Find the length of the leg adjacent to the 5-degree angle. So this side, of course, from the right angle, across from the right angle, is our hypotenuse. This is opposite. It's opposite, the opposite leg of 5 degrees. And this is the adjacent leg of 5 degrees. So this is what they're asking us to find, the leg adjacent to the 5-degree angle. Now the next question we have is, which trig function am I going to need? I'm going to write my acronym. Now I'm going to be using O and A. So I need to decide which one of these uses O and A. Sine uses O and H, cosine uses A and H, and tangent uses O and A. So we know we're going to be using the tangent. So we're going to write the tangent of 5 degrees is equal to our opposite over our adjacent. The tangent of 5 degrees is equal to, in this case then, 3 over x. And we're going to cross multiply, so we're going to end up with x tangent of 5 degrees equals 1 times 3, or I'm just going to write 3. And in order to solve for x, we're going to divide both sides by the tangent of 5 degrees. And now it's really easy to solve for x using our calculator. We're going to enter 3 divided by the tangent of 5. Tangent button is highlighted in red on my screen. And we're going to get, rounded to the nearest tenth, approximately 34.3 feet. All right, moving on to the last page. Now, sometimes we're going to need to find an acute angle in a right triangle when we're given two sides. And what we do is we use what's called inverse trig function. So I'm going to go to the calculator to show you what I mean. If you look here, right above sine, cosine, and tangent, you'll see sine raised to the -1 power, cosine raised to the -1 power, and tangent raised to the -1 power. That represents the inverse trig functions. That's inverse sine, inverse cosine, and inverse tangent. So I'll show you what I mean in the example, but anytime you are finding an acute angle in a right triangle, you're going to use the inverse trig functions. So it says use a trig ratio to find the measure of angle A to the nearest tenth of a degree. I'm going to label this as X. This is what I'm trying to find. And this is my angle of perspective. So the leg opposite my angle is right here. That's 7. Across from my right angle is my hypotenuse. And the leg next to or adjacent to my angle is right here. That's 4 inches. Now I'm going to be using the sides that they actually gave me. They gave me adjacent, they gave me opposite, but I don't have anything with hypotenuse, so unless I feel like using the Pythagorean theorem, I'm just not going to worry about what the hypotenuse is. I don't need it. I'm going to write down my acronym again, and I'm going to decide again which one do I need. Sine uses O and H, cosine uses A and H, and tangent uses O and A. Well, I have O and A, so I'm going to be using tangent. So I know that the tangent of X is equal to, I know that it's going to be O over A. In this case, that's 7 over 4. Now I need to get X all by itself. So like I said, the way I would do that is I'm going to take the inverse tangent of both sides. I'm going to use the inverse trig function. Now, when I take the inverse tangent of tangent, on the left side, I just have X. On the right side, I have inverse tangent of 7 over 4. Okay, so we're going to put that into the calculator. So we're going to do second tangent to use the inverse tangent function, 7 divided by 4. And I'm going to get a value rounded to the nearest tenth of 60.3 degrees. All right, let's try another one. We have triangle DEF. We know that F is the right angle. So right away, across from my right angle, I'm just going to go ahead and label this is my hypotenuse. Lowercase f represents the side opposite capital F, opposite angle F. So this is F. Across from capital D, we have side D. And across from capital E, we have lowercase a. Let me show you that again. So I have capital F, little f. I have capital E, little e. And I have capital D, little d. So capital print letters represent angles. Lowercase print letters represent sides. So we know that F is 13. We know that E is 5. And we're being asked to find the measure of angle D. Now, I don't know what side D is, or also called side FE. All right, I'm not going to use that. All right, but they're asking me to find angle D. So let me mark that. This is my angle of perspective. Now, the hypotenuse never changes. My hypotenuse is across from my right angle. And I need to decide now, what side is here? Is this adjacent or is it opposite? This would be considered opposite. This would be considered adjacent. So I'm going to write that in, that is adjacent. All right, I'm going to write my acronym, SOHCAHTOA. And I'm going to decide which trig function do I need. Sine is O over H. Cosine is A over H. Tangent is O over A. Well, I have adjacent and hypotenuse. I have adjacent and hypotenuse. So that means I have to use cosine. So I have the cosine of angle D is equal to the adjacent over the hypotenuse. So the cosine of D is equal to 5 over 13. If I want to solve for an angle, I'm always going to use the inverse function. I have to undo cosine, so I'm going to use inverse cosine. On the left side, I get side D, and on the right side, I have inverse cosine of 5 divided by 13. I'm going to put that in my calculator, and it says calculate to the nearest tenth of a degree. You're going to do second cosine to get the inverse cosine function, and 5 divided by 13. Rounded to the nearest tenth, I get 67.4 degrees. Okay, so that is it for our lesson on trigonometry. Lots of practice, I believe, will be necessary before you really start to get the hang of it, but don't forget the favorite acronym, SOHCAHTOA. Have a great day, everybody. Thanks for watching.